Okay, everybody, I wanted to just put together a quick video to explain the difference between using those two formulas that we talked about. How do you choose between the two different formulas for instantaneous rate of change? What I didn't mention in class, this is like right after class, I'm just sitting here in the library thinking about this, and I thought I'd make a video to maybe explain the difference. The point is, it really doesn't matter which form of the instantaneous rate of change formula that you use, but I think you'll find in practice, sometimes it's harder to get the answer because, well, let me explain why. So first of all, if we use kind of that original version, the limit as x approaches a of f of x minus f of a over x minus a, let's see what happens when we do this. So actually, we're going to take, in this case, the limit as x approaches 1 of f of x minus f of 1 over x minus 1. I'll just tell you in advance, the problem is that when you do all the math here, you do all the expanding and collecting and simplifying, the problem is going to force you to factor out a factor of x minus 1, which I think many of you can do, but some of you may not feel comfortable doing it. Let me explain why. So in this case, f of x, let's see, we have the limit as x approaches 1 of f of x, and then minus f of 1, which we're given is 5. Okay, now question is, how many people feel comfortable factoring that expression? You'd actually have to go back to synthetic division in order to factor this. So you know it should be factorable because when I try to plug in x equals 1, I get 1 plus 4, which is 5. 5 minus 5 is 0. And of course, 1 minus 1 is 0. So I know that there should be an algebra fix, and clearly, I say clearly, but it's clearly, it's going to be factorization. So how can I factor an x minus 1 out of the top? It's not quadratic. I can't do like what multiplies to 5 and adds to 4. It doesn't quite work that way. You actually would have to go to, well, if anything cancels from the top and bottom, it's going to be x minus 1. So I'd have to try to do synthetic division using x equals 1. So doing synthetic, I get 1, 0, 4, negative 5 are my coefficients of the numerator. And then 1, let's do multiply by the 1 is 1. We're going to add 0 plus 1 is 1. 1 times the 1 in the box is 1. And then 5 and 1 times 5 is 5. That's 0. Yes, because the remainder is 0, x minus 1 is indeed a factor. So the factorization of that numerator is x minus 1 times x squared plus x plus 5. And we still have our denominator of x minus 1, and we're taking the limit as x goes to 1. It's still 0 over 0, but by the way, we can now cancel x minus 1. And now what happens when we plug in x equals 1? Of course, we get, let me switch over to my highlighter. Of course, we get 1 squared, 1, plus 1, 2, plus 5, 7. Does the answer sound familiar? Of course it does. So the first way, in this case, was harder to factor, but easier to get the final answer. And the way we did it in class, we did the, I call it the H method, where the denominator is H. We'll take a quick look at that again. We're going to have the limit as h goes to 0 of f of x plus h minus f of x. I want to take that back. Hang on a second. We're doing it at a specific value, so it's actually a plus h minus f of a over h. Our a value, we're evaluating it at 1, so it's the limit as h goes to 0 of f of 1 plus h minus f of 1 all over h. Now, we did f of 1 plus h in class. Now, I don't have my notes with me, so I'm going to do this again really quick. You can fast forward through this part if you don't want to see it. F of 1 plus h equals, I'm going to do a shortcut. I know it's 1 to the third plus, I think it's 3h squared plus 3h plus, wait a minute, it's 1 plus 3h plus 3h squared plus h to the third. That's the x to the third part, and then it's plus, so I'm going to run out of room, it's plus 4 times 1 plus h. So putting that all together, putting it in standard form, I get h to the third plus 3h squared plus 3h, and then here's 4h, so that's 7h. And then 4 times 1 is 4, plus 1 is 5. Okay, so now I can go back to my limit. The limit as h goes to 0 of f of 1 plus h minus f of a, which is 5. And just for illustrative purposes, f of 1 plus h is this guy. F of 1 is this guy. Anyway, it's all over h, and algebraically, how does this clean up? The 5's cancel, and I've got h to the third plus 3h squared plus 7h all over h. We can take out an h from the numerator. Cancel, cancel. It's now evaluative, and I can plug in 0. 0 plus 0 plus 7 is 7. Either way, we get 7. So they both work, but I hope you see the difference in that the version on the left required some weird factoring. It doesn't always happen. Usually you can just pick either one and be happy using either one. So I didn't mean to make a bigger deal out of that than it actually was in class, but I wanted to give you some guidance in case you were confused by that. Most of the time it does not matter. But on the first day of notes, I did want to show you both methods. Okay, so that's all for the video. Thank you for watching, and I'll catch you later.